Hello, everyone. So in today's video, we are going to look at chapter 5, but this basically covers week 13 of our MECT 3360 AMS class. So in this video, we are going to discuss on the material handling. Okay, so like always, we are not going to discuss too much of theory, or in fact, like there will not be any discussion on any of the theoretical topics. So I will directly jump to one of the numericals and show you how to solve it. Okay, so when you watch this video, maybe you will not understand a lot of things. So take this video as a reference and make sure that you look at all the slides and understand each and every concept before you start solving your assignments and also prepare for the exam. All right, so in this chapter, to summarize, like we're going to discuss three different topics, which you can see here. So material transport systems. So what are different kinds of material transport components, different kinds of designs, their analysis, their pros and cons, and so on. So for example, a conveyor belt, forklift, so there are a lot of those, like even the robots, a simple cart, and so on. So there are a lot of these material transport systems, and we have the storage system and the automatic identification and data capture. For example, we use the QR code or even the barcode. So if you go to the Walmart, when you scan the item in the checkout, then it just automatically identifies the object with its barcode, right? So that is what we're going to discuss here. Those things are covered on these slides, but we're not going to discuss about that. And like I said, let's directly jump to all the way down. So all of these are different examples of material transport system. And so you see these automated guided vehicles. So we are going to work on the numerical problem, which calculates how many automated guided vehicles, AGVs, are required to perform a certain work. So that is our focus. And for that, scroll down. So all the way at the end. Okay, so here, analysis of material transport system. So we will use from to charts. Okay, so in your assignments and even in your exam, you will be asked either to develop the from to chart, or from using the from to chart, you might have to draw the other other things like the precedence diagram, flow diagram, and other kind of tables, and solve the numericals. Okay, so either way, you need this from to chart. So in your exam, maybe it will already be given as a part of your question, or you have to draw it on your own. So this is the from to chart on slide 50, which shows how many objects from a specific station goes to the other stations. Okay, how many objects are distributed from X station to all the other stations, and how many objects travel certain distance. So because if we have to calculate the number of vehicles that we need, then we must know how much they have to cover, how much they have to travel, how many work they have to do. Okay, so those are the two things we need. So we want to know how many work assigned it can do in a given amount of time, and how far it has to move. If if all the other stations are very close to each other, and the number of parts that we have to move between the stations is not too many, then maybe just one vehicle is enough. Okay, but if it has to cover a lot of distance, too many parts is processed per time, so we need more vehicles. And that is what we must calculate. Okay, so this is a simple example of how to construct a from to chart. You will understand when you look at it. So you can see the relation. Okay, so from you can see on the table as well as on the precedence diagram, we are just writing down from and then the stations, okay, and to and then the stations. So from 1 to 1, it's the same station, so no object or no work goes from 1 to 1. Okay, and from 1 to 2, okay, so from 1 to station 2, how many work is transferred? It is 9, and this 50 is the distance covered. Okay, so from 1 to 2 is 9 by 50. Okay, so 9 work and 50 some units of distance. Okay, so 9 by 50. And from 1 to 3 is 5 by 120. So 5 by 120. So this is the number of work and the distance the work has to travel to reach 3, and so on. Okay, so 4, and also sometimes it will return, but here none of the work returns to station 1. Okay, but in some of the examples it will return to station 1. All right. So using the precedence diagram, so you can draw, this table from to table using this diagram. Okay, it's easy to draw. If you have this, you can easily draw from to, and if you have from to, you can also draw the precedence. Okay, so drawing one of these from the other one is not that difficult. Like I said, if these numbers are given, you know that like from 1, the work or the parts travel to station 2, 3, and 4. Okay, not 1 and 5. So that means from 1, we draw 2, 3, and 4, and we write these numbers for each of these. Okay, and same goes for 2. So we can see from here that from 2, the parts only go to station 5. So from 2, we only have station 5, and so on. So we can draw between these two. All right, so let's look at other things. All right, so this is a very important formula that we use to calculate the number of the guided vehicles. Okay, number of AGVs, which is using this formula. And we can also use other formula, like sometimes this available time is not given. Okay, and sometimes we cannot calculate, because for this is calculated based on the traffic factor, availability, efficiency, and so on. So sometimes we don't have to calculate this available time. We might have to just calculate using this and this formula. Okay, the workload. But here what you must understand is what are these terms. So RF is the specified flow rate of total deliveries per hour. So this basically says how many deliveries a specific vehicle must perform, okay, in given amount of time. So from this also you can calculate number of vehicles. Okay, if available time is not given, but if you know this RF, then you can also calculate. For example, if you have to deliver 20 products in 1 hour. Okay, yeah, I'm just giving an example. Okay, so let me switch to here. So if you have to deliver 20 products in 1 hour, and if a vehicle capacity is let's say it can work 5 products per hour. Okay, it can only deliver this much. Then with these two information, you know that we need 4 vehicles. Okay, so sometimes we don't have to use the availability to or the available time to find out the number of vehicles, but all of those will be given in the question. So you will know that when to use this available time formula, or when to directly go from here and use these. Okay, all right, so these are the formula, and here on this one there are 4 things. Okay, so TL, so TC is the delivery cycle time. Okay, so a vehicle has to pick the object, load it on the picking station, travel to a drop-off station and drop it off. Okay, which means the unload, and it has to return back to its like resting area, wherever it is. So there are 4 times associated with it. So the first one, TL, is the time it takes to load an object, and then it takes certain time to travel up to a a drop-off station, and it takes some time to unload all the objects it has carried, and then it does not stay there. Okay, it has to make a return trip to some other station. It can be the station where it started, or where the pickup station, or any other station. So these are the 4 times. Okay, so TL, LD is the loading time. So sorry, not the loading time. So it is the time it takes to reach the drop-off station. Since here, okay, so LD is the length, okay, the distance, how much it has to travel to reach the drop-off station. Okay, so let me do here. So we will have a pickup, okay, drop-off. So here, Okay, so this vehicle has to load objects. Okay, so this is loading. So this is the time it takes to load is TL. And here, the vehicle has to now travel. Okay, so it has to go from pick off to drop off. So the distance it travels is LD. So the time it takes to travel this distance is given by, so we know that speed is equal to distance by time, right? So we want to calculate time. So time is equal to distance by speed, all right? So this is equal to, sorry, the time it takes to cover this distance is given by TD, okay? The time it takes to reach the drop-off is equal to the distance it has to travel, which is from here to here, divided by the speed of the vehicle, okay? So vehicle speed. And now, here, the drop-off station, okay? The vehicle now has to unload this, okay? We can say this is TU. So this is the unloading time. And now the vehicle has to return somewhere. Okay, the vehicle has to go somewhere, which is the empty travel time. Okay, so how much it travels after the drop off. Okay, so these are the 4 times associated. So here you can see that we must calculate these distance. Okay, so calculating distance is very important. All right, so let's look at this. And that is what we have to solve in this first example, okay, which is very straightforward. So consider the AGV layout in figure 10.14. Vehicles travel counterclockwise around the loop to deliver loads from. So in this one, okay, here you can see the diagram, okay, the layout, how much it has to travel. So consider the AGV layout. Let me try to write here somehow. Okay, not with this. Okay, draw. Yes, I want to draw. So consider the AGV layout vehicles travel counterclockwise. So counterclockwise is this direction. Okay, so the vehicle travels in this direction. Loading time at the loading station. So loading station is here. And the loading time is 0.75. So we know that this is TL. Okay, so the loading time is TL. And the unloading time at the unloading station. So this is TU. Let me just confirm what is the notation they are using. It doesn't matter, but yeah, it is TU. So we are interested in determining how many vehicles are required to satisfy demand for this layout if a total of 40 deliveries per hour. Okay, so this is the total delivery we must make. And now we need to calculate how much one vehicle can deliver. And that is how we can find out how many vehicles are needed. Okay, so must be completed by AGVs. The following performance parameters are given. So vehicle velocity, this is the velocity that we use to, for example, here, we use to calculate the travel time. So vehicle velocity, let's write VC. Availability, which is just A for this one. Okay, this is A. And traffic factor 0.9. So this is the traffic factor here, 0.9. And operator efficiency is 1. So all of these are given. So that means we calculate the available time. Okay, we can calculate right here. So available time is equal to 60 times the availability is 0.95. So availability means the time it takes. So the vehicle or the machines are not available 24/7. Okay, it has to be repaired, it has to rest, it has to charge, and so on. So if availability is 1, that means the vehicle is available 24/7. If it is less than 1, that means we cannot use it 24/7. So here it says we can use vehicle 95% of the time. Okay, so and FT is the traffic factor. So there will be many vehicles, not just one. Okay, and maybe the traffic congestion, like all the vehicles are moving between the stations, and sometimes it has to wait. So which you have seen, like for the food delivery robots on our campus, right? So if they see an object or the other vehicle, one has to wait for until the clearance. So that is the traffic factor, and EW is the efficiency. So efficiency is 1. Sorry, I haven't put the traffic factor yet. So 0.9, and EW is 1. So this gives us this available time, which I can directly see here. It's 51.3 Okay, so 51.3 minute per hour per vehicle. Okay, so that means out of 60 minutes in 1 hour, we can only use vehicle 51.3 minutes. Okay, so this is the only time the vehicle is used efficiently. All right, so this also plays a role. So when we calculate the number of vehicles, the efficiency, the traffic factor also must be considered. Now, let's calculate these, determine travel distances, loaded and empty. Okay, so this is the unload main and this is the load main, and we travel in this direction. Okay, so what is the distance we have to travel for the loading and unloading? Okay, so from vehicle travel counterclockwise around the loop to deliver loads from the load station to unload station. Yeah, so from this station, from loading station to unload station, we travel this direction. Okay, this is the counterclockwise direction. So from these dimensions, let's find out how much we travel. Okay, so this is 55 and this is 20. So this distance from here to here is 35, and this is 40, right? From here, so 35 plus 40, and from there to there is again 35. So the total is 35 plus 35 plus 40, which is 110. So for the loading, okay, the loading distance is 110. So the loading time is given by 110 divided by its speed. Okay, so the speed is, where was the speed? Yeah, 50 meter per minute. Okay, so this is 50. And so this is 2 point something, right? So 2.2. All right, so the loading time or time it takes to reach the unload station from the loading station is 2.2 minutes. This is not the loading time, sorry. And now the empty. Okay, so after the unloading, now it has to travel again to the loading station. Okay, using this path because it travels counterclockwise. All right, so using the same distance numbers here. Okay, this looks dirty. Okay, so we know that from here to here is 20. Okay, this is 20, this is 40, and this is 20. So the total is 80. So the empty distance is 80 and the speed is once again 50. So the time empty is 80 by 50, which is equal to 1.6. Okay, so 1.6 minutes. Now we have calculated, out of these four, we calculated this whole thing. Okay, we divided the distance by speed. We also did this, and the unloading time is given. Okay, so the unloading time and the loading time, these two are given here. And if we add all of that, it gives us the cycle time of the delivery. Okay, so it takes us 5.05 minutes for one delivery for one vehicle. So one vehicle needs 5.05 minutes to do one delivery. Okay, so here we haven't even used the available time. We must use that as well. Now, so ideal delivery cycle time. So in ideal delivery cycle time, what are the number of vehicles needed? Okay, so 40 delivery per hour. So 40 delivery per hour. Okay, so in 1 hour we have to make 40 deliveries. So the total time, because for one delivery we need 5.05 minutes. Okay, so for one delivery, and we have to make 40 deliveries. So that means in 1 hour, okay, so 40 deliveries, and each delivery takes 5 minutes. So the total time it takes to make 40 deliveries is 40 times 5.05. Okay, so this is calculated using this one. Okay, so we know that TC is 5.05 and RF is how many deliveries we need to make in 1 hour. And using these two, we calculated the workload. And now workload is 202 minutes per hour. And the number of vehicles needed is equal to workload divided by available time, which is this. Okay, and if we do that, we can calculate how many vehicles are needed. All right, so the workload is 202, and this is 51.3. So I guess this is 4. So we need 4 vehicles to do this task. All right. So this is 3 point something. So you need, first of all, you must specify the number of vehicles in a whole number. It cannot be in decimals. And the whole number must be one larger than this one. So if it is 3 point something, write 4. Okay, even if it is 3.01, you can write 4. Okay. All right, so this is one part. In the next one, we are going to look at, so I'll help you to solve one of these, which is your assignment. So I will discuss about this one as well, how to solve this, which will be the second part. All right, so welcome back to this week 13 lecture. We're solving the numerical for the material handling. And here we are trying to find out the number of vehicles that we need to deliver, certain deliveries per hour. Okay, so we looked at these numericals. Okay, this was very straightforward, where you could easily calculate each of these parameters, and it was just using the formula and putting values for each of these parameters. Okay, so I hope it was not too difficult for you to understand. And the reason why this numerical is here is to make you understand how to use these parameters. Okay, so in that numerical, we have made use of all of these. Okay, so all of these. All right, so the next one we are going to look at is from your assignment. Okay, so this is supposed to be done by you, not me. But I will try to explain this. Okay, so and you will, so in your exam, you will get one question similar to this one. Okay, so be ready for this. And this is one of the reasons why I'm solving this one for you. So obviously you will not get this exact question on your exam, but still this is to prepare what kind of numerical to expect. Okay. All right, so this is from assignment 5, and let's read this one first. So a flexible manufacturing system is being planned. It has a ladder layout. So that means the stations are in step by step, okay, in the ladder layout, and uses a rail guided vehicle system. So we have this rail guided vehicle. So all these black, path is the rail guided. So on these, the parts move from station 1 to station 2 and so on, okay? So all work parts are loaded into the system at station 1. So station 1 is the source. So this is the first station where all parts are loaded. And from station 1, we distribute the parts to all the other stations and move to one of the 3 processing stations. So all the parts come to station 1, but from station 1, some of the parts move to 2, some of them move to 3, and then to 4, and then brought back to station 1 for unloading. Okay, so from 1, we move it to either 2, 3, or 4, and after everything is done, we bring it back to station 1. And once loaded into RGV, each work part stays on board the vehicle throughout its time in the FMS, okay, which is the flexible manufacturing system. So in this one, load and unload times at station 1 are each 1 minute. So both TL and TU are 1 minute. Processing times at other stations are this, okay? So for each part, it takes 5 minutes at station 2, 7 minutes at station 3, and 9 minutes at station 4 to process, okay? So because from station 1, we send the parts to 2, 3, and 4, and at 2, 3, 4, we do certain process, right? So the time it takes for each part in each station are given here. So hourly production rate of parts through this system is 7 parts through station 2. So in 1 hour, station 2 can do 7 parts, 6 from station 3, and 5 station 4. And develop the from to chart for trips and distances using the same format as table 10.5. And this is where our question begins. Develop the network diagram and determine the number of rail guided vehicle systems. So this is the ultimate thing we want to calculate. All right. So like I said in our previous example, which we did, the rail, the from to chart and the precedence diagram both are related. Okay, so but here none of these two are given. So for from to chart, so for this from to chart, we need two things. Okay, sorry. Let me see if I'm sharing or not. No, wait. Yeah, so for from to chart, we need parts and distance. Okay, these are the two things we need. So what that means is that how many parts go from 1 to other stations, from 2 to other stations, from 3 to other stations, and what is the distance covered. Okay, so here the distance are given like this. All right, so now let's calculate the distance it travels from station 1 to station 2. Okay, all right, so from here, let me draw right here. So from station 1 to does it say which way do we follow? Okay. It's been planned. Yeah, I think it's not given. Okay, so which way do we go from 1 to 2 or there? But here I'm going to use, so it's not specified here. So I'm going to use the clockwise direction, not the counterclockwise. All right, so from 1 to 2. Okay, let's say we do the loading this way. So after loading, we send it this way and we bring it back the other way. Okay, and now from 1 to 2, what is the distance it has to travel? Okay. All right, so let's do this. So this distance is 10. The vertical is 10, the horizontal is 10. So from here to here is 10. From here to here is another 10, and from here to here is another 10. So from 1 to 2, it covers 30 meter. Okay, let's take unit as meter. It doesn't matter. Okay, so 30 as meter. Sorry, 30 meter. And from 2 to 1, let's say this is the direction of unloading. I think it should have given somewhere. Okay, so yeah, the direction. All right, so let's take it this way. So the empty one now is brought back using this distance. So now this distance is 5, this distance is 10, and this distance is 5. So from 2 to 1 is 20. Okay, so this way we can calculate the distance from 1 to 2, 2 to so let's calculate that. All right, okay, here distance from 2 to 1. Okay, sorry, let's start from 1 to 2. From 1
You'll need an app for me to help you with that. You could try searching the App Store.
So 1 to 2 is so 10 plus 10 plus 10, which is 30. Okay, so station 1 is here, station 2 is here. So this distance is 10, this distance is 10, and this distance is 10. So going from 1 to 2, okay, I'm following clockwise, and coming back is 5, 10, and 5. Okay, so from 2 to 1 is 20. Similarly, from 1 to 3, okay, you can check the drawing. So it's going to be another 10 here. All right, so the station 3 is here. So that will be 10 more than 2. So it will be 40, and 3 to 1 will be 10 because this is 10. Okay, 10 more than this 2 to 1, so which will be 30. And 1 to 4 will be 10 more than 1 to 3, so it will be 50. And 4 to 1 will be 40. Okay, so you can easily calculate this distance from here, from this diagram. All right. So I don't have to explain too much from here. But from here, now we can draw the from to chart. So we know that 7, okay, let's see here. So 7 parts through station 2, 6 parts through station 3, and 5 parts through station 4. Okay. And okay, so processing time, let's find out. So processing time at all the stations are 5 to 7, 9. Hourly production rate of the parts through the system is 7 parts through station 2, 6 parts through station 3, and 5 parts through station 4. So yeah, station 2, station so 7, 6, and 5. So in our from to chart, okay, so in our from to chart, what we have is, so we have from station. So from station 1, we send it to station, we will not send any parts to station 2. So we can make this table anyway. Okay, so there are 4. So from is in this direction, 2 is here. So from 1 to 1, we don't send anything. So from 1 to 2 or 2 to 1, it doesn't matter. Okay, so it is 7 parts. Okay, so but the difference is going from 1 to 2, 7 parts travel 30 meters because the distance from 1 to 2 is 30. So going from 1 to 2, we have 7 parts, okay, which travels 30 meters. And from 2 to 1, okay, so from 2 to station 1, we have the same number of parts, but now it travels only 20 because while returning, we have less distance. So similarly, from 1 to 3, we have 6 parts which travel 40 meters. And while returning from 3 to 1, okay, so from 3 to 1, it travels 30 meters. And for 1 to 4, while we deliver, it travels 50 meters. So 5 parts, it travels 50 meters. And while returning, it travels 40 meters. And all the other are 0, okay, because we can write 0 by 0 or just 0, it doesn't matter. We are not going to use this information. Okay, because we don't send any parts, any number of parts to other stations. So only from station 1, we send out the parts and we receive back at station 1 only. So from station 1, okay, we send 7 parts, it takes 30, it travels 30 meters, but coming back from station 2 to station 1, we have the same number of parts, but now it travels 20 meters and so on. So this is the from to chart. Okay, so we are done with the first part of the equation. And second is the network diagram. So let's draw the network diagram. And as you can see from this one, all right, so all the parts go from station 1. All right, so we can draw station 1 here, and from station 1 to station 2, okay, so 7 by 30, this is when we go to station 2. So the arrow is in this direction. And when we come back, it travels 20, okay? And same for station 3. So for station 3, let's draw it somewhere here. So when it goes to station 3, it travels 6 by 40. And while returning, it travels 6 by 50. Sorry, 6 by 30. And for station 4, okay, so when we go to station 4, it travels 5 by 50. When it returns, it travels 5 by 40. All right. So this is simply like drawing using the from to chart. And now the second part is also done, okay, where we have to draw the precedence diagram. Now in your exam, you will either get the precedence diagram and you will be asked to draw from to and solve the rest of the numericals, or you will be given the from to chart, and from to chart you will be asked to draw the precedence or directly calculate the other things. All right, so the third one is to calculate the number of vehicles needed. Okay, so for number of vehicles needed, if you remember, we have these 4 times. Okay, so the delivery time it takes for one vehicle is equal to the loading time. Okay, the time it takes to travel to drop off station, unloading time, and time it takes after emptying the vehicle. Okay, these are the 4 times that we need. So the empty. All right, so let me see the times. Load and unload times. Okay, so TL and TU both are 1 minute. And processing times is given. So 5 at station 2, 7, 9 hourly production rate, this. So the empty time is not given, so we can write it 0. So out of these, okay, so out of these, we have this is 0. Okay, these two are 1 and 1. All right, so first of all, let's calculate the distance. Okay, so let's calculate the distance. So we can calculate the distance using this precedence diagram. So we know that 7 parts travel 30 and 20 meter. So if we just look at station 1 and 2, let's forget about 3 and 4. Okay, let's calculate how much distance it travels, between station 1 and 2. So the distance it travels is like when going to station 2 from station 1, it travels 30 meter, and when it returns back, it travels other 20 meter. Okay, so total of 50 meter, and 7 parts travel this 50 meter. Okay, so for each part travels 50 meter. All right, so I will just cut this break part from the video. Okay. All right, so we were looking at calculating the distance. Okay, so we were discussing how much each part would travel. So if we just look at between station 1 and station 2, the total distance, okay, if we run the full cycle, is 50 meter. Okay, so 30 meter to unload, and after loading, 30 meter until the drop off station, and after that, returning to 1 is another 20 meters. So the total is 50 meter. So these 7 parts travel 50 meter. So each part, okay, each part travels 50 meter from station 1 to station 2. So that means the total distance, if we count for all 7 parts, will be 7 times 50, okay, which is 350 meter. So the easy way to do is that we have 7 parts, and these 7 parts travel 30 meter going to station 2 and 20 meter coming back, okay, which is again same 350 meter. I'm not doing anything new. So we do the same for station 1 and 3. Okay, so this is the first is for station 1 and 2. So for station 1 and 3, there are 6 parts, and each of these parts travels 40 meter and 30 meter coming back. Okay, and then we have 5 parts from station 4, and it travels 50 meter and 40 meter. So now the total, so the average, okay, so for each part, so this LD, so right now we are calculating, okay, so this is the total distance, right? So you can see from this expression that this is the total distance from 1 to station 2 for all 7 parts. So this is the total distance from 1 to 3, okay? And the other one is the total distance from 1 to 4. So now we need the distance traveled for part. So the total number of parts is 7 plus 6 plus 5, okay? So this distance is shared between these parts. So this gives us how much? So this first expression is 350. The other one is 4 plus 3, 70. 70 times 6 is 420. Plus 50 plus 40 is 90. Times 5 is 450. Divided by 7 plus 6, 13, 18. Okay. So 350 plus 42 plus 450. So 870 plus 350, which gives us 1220. 1220 divided by 18. Okay. So this gives us 67.7 meter. So this is the distance, the average distance per part. All right. Okay. So now we have the processing time. Right. So this is the LD. Okay. If we divide it by the speed, okay, if we divide this distance by the speed, then we will find out. So here, okay, so in this one, we are currently doing this LD part. Okay, so we're just, so LE is 0. Okay, in our case, we don't have to calculate this, and we are calculating LD. We know the speed, so this part is done. Okay, and loading, unloading, and there is also the processing time. Okay, so we must add that as well. So where is the load and unload times? Okay, these are given. Processing times at other stations are 5 minutes, 7 minutes, and 9 minutes. Okay, so this gives us the average time. All right, so let's calculate the processing time also. Let's say this is TP. Okay, so processing time, 5 minutes at station 2. So how many parts are there in station 2? 7 parts, and for each part it takes 5 minutes. Okay, so processing time at each station. Okay, I'll draw the station here. This is station 2, this is station 3, and this is station 4. Okay, and there are 7 parts in station 2, 6 in station 3, and 5 parts in station 2. Sorry, 4. Okay, and for each part, the processing time is 5 minutes here. Okay, 7 minutes here, and 9 minutes here. So it takes 9 minutes for each part at station 4. So the total processing time is, so at station 2, for all 7 parts, it takes 7 times 5 minutes. Okay, it takes 35 minutes in total for 7 parts. Similarly, for station 3, it takes 7 times 6, and here it takes 9 times 5. And the total processing time we add, okay, we add these two, add all 3. And so this gives us, okay, so how much? 735, 7 times 6 is 42, which is 77 in total, plus 9 times 5 is 45. Okay, so 77 plus 45 is 122. So the total is 122 minutes. Okay, for all the stations and all parts. So for each part, okay, we do the same. All right, so the total is 122 minutes for how many parts? 7 plus 6 plus 5. Okay, so 7 plus 6 is 13, and 5 is 18. So 18. All right, and this gives us 18.6. So 6.78 minutes. Okay. Now for each part, this is the average processing time. All right. Now the total time. So total time is, okay, we have the loading plus unloading time. Let's do TU and TL, which is the loading and unloading time, plus the processing time, plus the time from traveling the distance. Okay, and there is no TE. Okay, so TE is equal to 0. And this is 1 minute. This is also 1 minute. This is 6.78 minute. And TD, okay, the travel time average is this divided by the speed. Okay, so the distance is 67.7 divided by the speed at which it travels is 60. Okay, it's given. Oops, sorry, I forgot to say it here. Oh, had been doing this I don't know since how long. All right, so let's start from here, from the processing time once again. I'm sorry about that. All right, so the processing time, okay, we have 3 stations. Okay, let's write it TP. So we have 3 stations: station 2, station 3, and station 4. And station 2 processes 7 parts. This one does 6 parts, and this one does 5 parts. And for each part, it takes 5 minutes. For each part, it takes 7 minutes. For each part, it takes 9 minutes. Okay, so the total processing time is, so for 7 parts, station 2 takes 5 times 7 minutes. Okay, and for 6 parts, station 3 takes 6 into 7 minutes. Okay, so one part takes 7 minutes. So station 2, station 3, and for 5 parts, station 4 takes 9 times 5 minutes. So the total will be 122 minutes. Okay, so this is the total processing time. And now for each part, so this is for 18 parts. Okay, there are 18 parts in total if we add for all stations. So for 18 part, it takes 122 minutes. So for each part, okay, processing time is 122 divided by 18, which is 6.78 minutes. Okay, so this is the average processing time. And now, so the time we have, okay, so the total time we need, okay, or we have used are for the delivery. So first of all, let's start with the loading, and then the delivery time, and then the unloading. Also, we have the processing, and there is no this TE, okay, the empty time is equal to 0. Okay, so only this part is 0. So the loading time is 1 minute. The delivery time is the distance divided by speed. So we travel 67.7 for each part. Okay, so for each part we travel 67.7 at 60 meter per minute. Okay, so this is the speed, and TU is unloading. This is also 1, and the processing time is 6.78. Okay, so the total time, if you add 6.78, 7.78, 8.78 plus 1 point something, okay, so this will give us 9.91 minute. Okay, you can use calculator. I have it with me. So yeah, so it will give us 9.91. So this is the cycle time, okay, delivery cycle time. So the best we can do, okay, this is the best when we don't have any traffic factor, efficiency is 100%, okay, everything is working well, vehicle is available all the time. So in that situation, we can deliver one product, okay, on average, okay, one product in 9.91 minutes. So now let's look at the other part of the equation. So flex if vehicle speed and the traffic factor, we now have the traffic factor, okay. So the traffic factor is 0.85. We can divide this number with a traffic factor. Okay, so let me go back. So I'll remember this number, 0.85. All right, so what this means, okay, so this means it takes 9.91 minutes for one delivery. Okay, so now let's find out how many delivery in 1 hour. Okay, so in 1 hour, so if it takes 9.91 minutes for one delivery, so in 1 hour, which is equal to 60 minutes, okay, so how many can we deliver? It is 60 divided by 9.91. Okay, so this is how many we can deliver. But with traffic factor of 0.85. So this is like efficiency, okay? So we can, so out of this, like this time, okay, we lose 15%, okay? So we are slow by 15%. So now let's multiply this by 0.85, okay? It's efficiency. So because of traffic factor, we will have only this much delivery, okay? So which is equal to 5.15 deliveries per hour. Okay, so this is like efficiency. You can also do it right here. Okay, you can divide it right here. So what you can do is, let's say one delivery, 9.91 minutes. Okay, so this is the ideal without any delay. Now with 0.85 traffic factor, okay, so with this traffic factor of 0.85, so logically it should take longer, isn't it? So if it takes 9.91 minutes without any delay, with some delay, okay, which is 15%, so with some delay it should take longer. So for that we divide it by 0.85, okay, and if you do this, okay, so 9.91 divided by, let me use the calculator, 9.91 divided by 0.85 is 11.7 approximately. Okay. So now with the delay, it takes us this amount of time. All right. So for one delivery, it takes 11.7 minutes. Or in 60 minutes, we can deliver 60 divided by 11.7, right? So let's do it again. So this gives us 5.13. So these two are equal. Okay, here I have approximated, so this number is almost equal, but we're basically doing the same thing. Okay, there is no difference. So this is just unitary method. Okay, and you can also use this formula. And like I said, sometimes you don't exactly have the same parameters. Okay, you will not see. So the traffic factor is here, but you will ask me where do we use the traffic factor here? But if you understand what these terms are, then it's easy. Okay, so just practice this. This is just a unitary method. You don't even need this formula to solve. Okay, and now let's look at the question. So, okay, determine the number. All right, so how many deliveries should we make? Okay. So we can deliver 5.15. So one vehicle can do 5.15 deliveries per hour. Okay. So the total parts are 18. Okay, let me go back. So to deliver all the parts, okay, here we don't have a specific demand. We just have to deliver all the 18 parts that are distributed to 2, 3, and 4. So on average, okay, on average, we can deliver 5.15 parts in 60 minutes, okay, or in 1 hour, which is 1 hour. So for 18 parts, so how many vehicles do we need? Okay, so this is for one vehicle. So one vehicle can deliver 5.15 parts in 1 hour. So how many vehicles do we need? It is 18. Sorry, it is 18 divided by 5.15. Right. So which as a whole number will be 4. So 4 vehicles to deliver those 18 parts. So if in the question it asks you to find out for a specific number of deliveries, you write the number of deliveries. But here it does not ask you that. So you just have to deliver all these parts which are mentioned here. Okay. Yeah. So hourly production rate. So for each for 1 hour, the number of parts are given. So 7 in 2, 6 in 3, and 5 in 4. So the total number of parts we must complete in 1 hour is 18 in total. Okay, and this is what we deliver. Okay, so yeah, you have to read all of these carefully to solve. Unlike this one where it directly asks you to do 40 delivery in 1 hour. In this question now you count total number of parts, which is 18 in 1 hour. Okay, for all stations. And yeah, that's all. So yeah, I hope this was helpful. So yeah, that's all for this recording.